brief description of how you did the problem. Here we go. Number one. Choice was 1. Yep. And how'd you go about it, Matt? Okay, I can plug it into my calculator, plug each multiple choice in the calc. I also like to go over anytime you plug it into the calculator. What if this was a non-multiple choice question? You had to come up with it on your own. All right. Anybody remember what these are called here? Zero, solutions, roots, answers, right? One of them is what? X equals -3. Give me another one. X equals 2 and X equals 3. All right. If these were your answers, what must have been your factor here for X equals -3? X plus 3, X minus 2, and X minus 3. All right. All equal to 0, or in this case, P of X. All right. And if you do, here you go, X plus 3 times X minus 3, you get X squared minus 9 times X minus 2. So that's the other way, non-calculator, to do it. Any questions? Thank you, Matt. Okay, going on to the next one. I know a lot of people, I watched some of you do it yesterday, especially my 6th period class, get a little concerned because you see ln. Okay, no big deal. You guys know how to solve this at this point, I hope. All right, at this point, we've done a couple of them already. So here we go. Need a little help. 5, ready? Any help solving this? 5? Okay, we'll do it together. Let's go. Got to get the 8 out of there. How? Divide by 8. X plus 3. What do I have on the other side? 6. Where is the variable? Is it in the exponent or is it the base? Exponent. So if the variable's in the exponent, how do I get it out? I use what? Logs. So I take the X plus 3, move it down, and what do I do with the 2? Well, what did you just tell me I needed to do here? Okay, it's down now, but what did you tell me? What did I need to use here? Because the variable is an exponent. You mentioned it 30 seconds ago. So I'm going to take log of 2, and whatever you do to the left side, I got to do what here on the right side? Log of 6. Everyone all right so far? All right, bringing that down. Okay, still have to get this by itself, so get rid of the log 2. How can I get rid of the log 2, Emma, still? Divide by log 2. Divide by log 2. Yep, everyone good? You're going to get a decimal. I didn't write it down. I'm trying to go quick here. X plus 3. I'm just going to keep it log 6 over log 2. And finally, Emma, I still got that 3 there to solve for X. So how do I get rid of the 3? Okay, so my final answer is going to be X equals log 6 over log 2, whatever that decimal was, and then subtracting 3 from that answer. Then you go back to your multiple choices here and find out which one's equivalent to this decimal, which I do have, -0.415037. Everyone take a look at your calculator if you don't have it out. Everyone see the left-hand side. Everyone see the LN button. That's how you can check which one of your multiple choice answers, obviously not number 2, is equivalent to that -4.14037. And I believe it came out to be choice 1. Yep. Okay. Everyone all right? Yes, Brendan. I'm not going to say that. Certain cases they are, yes. But we'll review that when it comes up. Okay, but no, they're not the same, though. Everyone all right? All right, here we go. Number 3. I don't know if that looked familiar or not. You have seen it on a previous test before, but 19. Choice 3. That's going to be the most biased. Why? Here's why. You are self-selecting yourself. That's why. If you take a look at choices 1, 2, and 4, you are being selected by somebody else randomly. Versus number 3, you're choosing yourself. That's why that's going to cause the most bias. All right. So self-selection. That's what I like to call it. Because you are self-selecting yourself, that's not even close. Selection. That's going to cause the most bias. Okay. versus somebody picking you randomly. All right, not too bad. How about 4? Oh, now we're getting good here. Now the fun starts with number 4. Here we go. 8. What do you want to do? So you're distributing? Yeah. Okay, what do you get when you distribute? Negative 24, I got that. X squared I to the 4th. Yep. 30x. Okay, stop. Everyone all right? All Brendan did was distribute. Now he's going to our clock. And 0, I to the 0, I to the 1st, I squared, I to the 3rd. 1, I, negative 1, negative I. All right, let's roll, stud. I to the 4th. Right? Because I start repeating now. I to the 3rd, I to the 4th. So if that's 1, what's left on the left side there, Brendan? No, hold on. I'm just going right here. If that's 1, what do I just get on the left side? Everyone good? I to the 4th is 1. Okay, keep going. I to the 3rd. So if I have negative I here times the 30, that's going to give me negative 30x I. Yep. And with choice, we have choice 2. Yep. Any issues? Just knowing your powers of I there. Knowing the clock. Knowing the clock. Good job, Bren. Here we go. 25. And by the way, I won't call on anybody twice in one day. 10. 10. Okay, what are you doing? It says find the value of R of 2. What are you doing with 2? Okay, this is a 2-pointer. This is going to be worth easiest 1 point you have. Store it in your calculator. Okay, or some of you plugged it in. You could plug it in. It's just I would store it in the calculator though, just to be on the safe side. And what do we get when we plug in 2? R of 2 is equal to? Yep, go ahead. I'm just saying, after you plug in 2, what's our final result? Negative 6. Boom. Okay, everyone's good on that part. Just plug it in. That's all that is. Plug and chug. Store button on your calculator. If not, plug it in. Just plug in 2 and figure it out. All right, here's the tough part. What's this answer tell you about x minus 2? Is it a factor of R of x? Now, there's a couple ways we could do this. Okay, couple ways. If this is a factor, and I'm just going to show you the different ways. I'm not going to actually do it. You can actually, using long division, see if it goes in evenly, and you should get a remainder of 0 if it's a factor. You should get remainder equal to 0. Okay, remainder equal to 0. That's one way. I probably wouldn't prescribe that way. All right, but there's other ways I could do it. What was the alternative you learned after you learned long division? Synthetic division, right? So you could also take, if x minus 2 is a factor, what's going to go in that little box there? 2. And then you could do, what do we have here? 1, negative 4, 4, and negative 6. Synthetically divide and see if you come out with 0. Quickest way possible is the following way. And this is why you did the work up here. Again, if x minus 2 is a factor, going back to you, Olivia, what would be a solution then? X equals 2. Everyone agree? X equals 2. Well, if x equals 2 is a solution, when I plug it in, I should get 0. Did I get 0? No. Okay. If x minus 2 is a factor, ready? Stick with me. That means x equals 2 is a solution. And if I plug in 2 to the function, I should get 0 back. But what did you get in the first part? Negative 6. Okay. So that is not a solution. All right. Error. X minus 2. So x minus 2 is not a solution. Because R of 2 is equal to negative 6 instead of 0. And again, these are 3 different ways you can show me why x plus 2 is a factor or not. Okay, long division, synthetically divide, or use the remainder theorem up here, which is I should have got out 0, but I got out negative 6 instead. All good? Any other questions on that before we get to this last one? All right, we're making good time here. 26. Let's see. Last one. 4, 6. You'll find him tomorrow. 21.
I put it into bars. Stat. Second distribution bars for distribution. Normal CTF.
Boom, there it is. Whole problem.
Plug in the whole thing.
Why? And then how did I know to go to normal CDF? Everyone ready? Follows A. Normal distribution, weighed less than 8.25. So yeah, all this is a normal CDF problem. What goes first? Lower bound. If I'm going 8.25, less than 8.25, what's my lower bound? Remember how we wrote that? -1 E99. Upper bound. Keep going, Jess. Go ahead.
Upper bound is
5. Right? Mean goes next. 8, and the standard deviation last.
standard deviation is
0.5. There it is. Normal CDF. How easy of 2 points is that? Okay, let's say you didn't do that hot on the multiple choice. Maybe you're not up to those 27 points you need. Whew, boy. All right. You just got a free 1 point up here. Here's free 2 points right here, knowing it's normal CDF. Nearest percent. Remember, your calculator will show a decimal on the screen. Multiply it by 100. Jess, what do you get? What'd you get for percent? Thank you very much. All right, guys. Questions at all? Yes, Jess, go ahead.
The first time I did it differently than that. For the first number, I put down 0.
And still got the same thing?
Yeah.
Okay, yeah, you can do that everyone because in this case right here there are no negative values because you are talking about bags of pears and their weights.
Yeah, exactly.
So yes, so 0 would be fine. Okay, but when there are negative values to try out, that's when you want to get the -1E, and you can never go wrong with the -1E99. Okay. Anything else? Okay, you're gonna have some more tonight to do. I'm not gonna overbear you with this, but I do want you to try some out. Questions before we get going with our stuff we have to do in class. Okay, please have your reference sheet that's not on the non-formula sheet. Formulas you need to know not on the reference sheet. Just make sure that's by your side because I know for a fact we're going to have to write something in there today. 33, everybody, 33. Oh, you remember these, I bet. I don't know. Some of you may have loved them. Some of you may have hated them. And some of you with crappy penmanship, your teachers probably hated grading them. 33. All right, here we go. Let's get right to it. We got some work to do. Calc's ready to go. Okay, we need to find the values of x, y, and z up here. First thing we need to do is eliminate one of the 3 variables. Keep the other 2. So do you see up there, using 2 equations at a time, a variable I can eliminate very quickly? Everyone look at the first and the third equation. Yes, you can eliminate x real quick. So what we're going to do is we're going to take that first equation, put it on top of the third equation, get the x out of there, and tell me what you have left. So the x's are gone. What's left? How many y's? Let's roll. How many y's? 4 y's. What about the z's? -4z. And don't forget about the numbers on the right. 12. Why do I have 4z? I got it. Try that again. 4y. There we go. Everyone all good? Okay, you have decided to eliminate the x's. So now what you need to do is pick another 2 equations and eliminate the x from it. Okay, that's what you decided to do, so we're going to continue doing that. All right, I need something else with a y and a z in it that has no x. So you guys, your choice, which 2 equations you want to use. I want to get the x out of there. Which two equations you want to use? 1 and 2? Everyone all right with that? You could do 1 and 3 if you wanted to. Or, excuse me, 2 and 3. That's fine. All right, if I go 1 and 3, ready? X plus 1 and 2, excuse me, plus z equals 1. And you're telling me also to do 2x plus 4y plus 6z equals 2. Everyone agrees the x's do not eliminate themselves like they just did previously. Okay, so we need to multiply this equation by something so it'll eliminate that 2x. What do you want to multiply by? Negative 2x. Good call. So let's multiply by negative 2. So now negative 2x minus 2y minus 2z. Don't make the mistake. Hey, I'll admit it. I made the mistake a period ago during my free period while I was doing these to make sure I could do them. I made a mistake. Don't forget to distribute it on the other side of the equal sign. All right. I had to go back, live it. I made the mistake quick, so at least I didn't have to erase a ton. Negative 2. Okay, go. Here we go. What do you got for me? X's are gone. See ya. What about the Y's? 2y. Z's plus 4z equals. All right, there we go. Okay, everybody good? Now you take both of these and solve them. All right, so I gotta say organized here. It'll drive me nuts. So I eliminated the x's. So here's what I have. 4y minus 4z equals 12. And I have 2y plus 4z equals 0. All I did was rewrite it. Oh, you suckers are lucky, huh? What do you notice right away? Z's are gone. I don't have to multiply by anything. The z's are gone. Nice. I like it. All right. How many y's are left? 6y equals 12. Y equals 2. You guys ever remember last year having that bad feeling when you got like 2.6592 and you're like, I did something wrong. I did something wrong. That's the worst. All right, we're good. So we got 1 out of the 3 done. What other variable do we want to find now? Well, there's only one I can find. Z, right? So how do I find z now? Take your y equals 2 and plug it into one of the two here. Anybody have a preference which one we plug it into? Second or top or bottom here? Because it's a plus sign, you got it. I don't blame you. Okay, so I'm going to take 2y plus 4z equals 0. Substitute in 2, right? Go ahead, solve for z. Z equals -1. 2/3 there. What do I do to find x now? Go back to one of the original 3. Plug in your x and your y. I mean your x and your y and your z. I'm going to ask, but I know the answer already. Which one do you want to plug it into? Always 1, kid. There we go. So x plus 2 minus 1 equals 1. I think hopefully you guys can handle the rest. X equals 0. And if you're unsure, what can you do? Because you're there for 2 hours minimum. Go back in. That's the great thing about a store key on your calculator. You can store all 3 variables in, type in each of the 3 equations, and make sure you get 1, 2, and 11. That's a 3-pointer right there. 4-pointer. Whew. Ding, 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 ding. There it goes. Way past 27 now. Questions? Everyone all right on that? What, Matt? Can you get partial on these, or is it like parts 2 through 4, you can get partial credit. Multiple choice is right or wrong.
Part 2, though, it's very tough to get partial credit because it's 2 points. It's very hard to earn a point. It's either really right or wrong, but there are instances where you can get partial credit. Like on that one we did with I did with Olivia with the R of 2. You know, you get a point for that one. You maybe not get a point for the second one. Okay. Oh, here we go. A little dot plot. 36. Yes, a little stats revisited. This was on the stats test, which I know have yet to give back because I'm waiting for the day to review stats all at once. All right, but this was on your test, and we did not do so well on this question in particular. All right, go ahead and read through Charlie's automotive dealership real quick. All right, let's get right to it. The dealership wants to be, ooh, there it is, 95% confident. Give me an interval that will be in the 95% confident range here. All right, so anybody remember what we need to do first here before I find the confidence interval? Well, margin of error, right? Margin of error. Anybody remember how to find margin of error? Plus or minus 2 times standard deviation, yes, which is given to you in the problem in the dot plot. You do not have to calculate it out yourself. We wouldn't make you count all those dots and put them in your calculator. Plus or minus 2 times 0.078. And it's plus or minus, that's just the margin of error. How far away from the mean most of them are. How do you find your actual 95% confidence interval? Anybody remember that one? Mean plus or minus margin of error. Yep. And the mean, again, is given on the dot plot for us. 0.506 plus or minus the margin of error we just found, 0.156. I'll give you guys a second. Add and subtract it from 0.506. And I know some of you made this mistake on your test. What are you getting for the low end of the interval? Point? Yeah, okay, that's no problem. Here's where you messed up, though. You didn't read the rounding directions. Nearest hundredth. You didn't have to worry about it with the 0.35, but with the 0.66, what is it, 0? 2? Yeah, it's not 0.662, though. It's 0.66. Okay, don't put 0.662. That's nearest thousandth. We need 100th. All right, ready? Everyone all right? Finding the confidence interval and the margin of error. All right, well, they went out, they did a sampling, and it came back 32.5% of the people want the new procedure. They decide not to implement it, use statistical evidence to explain the decision. Here's what a lot of you did on the unit test, unfortunately. You're like, oh, 32.5%, that's less than 50, that's why. No, that's not why. What did we just find? Our 95% confidence interval, and where's 0.32? Outside. Because here's, ready? I could have easily said 42%. And some of you still would have told me, oh yeah, don't do it because it's less than 50. But 42 would have been in our confidence interval, which would have been okay. It has nothing to do with being not 50%. It has everything to do being outside the confidence interval. Okay, so 0.325 is what? outside the 95% confidence interval. Not because it's not 50. Remember, it doesn't have to be exactly 50. We could get away with 44. What do you mean, like 0.78?
Yeah.
Then no go. Okay. Yep. It's got to be within the confidence interval. Okay. We all right? You got your sheets out? Might be a good idea to write down margin of error and confidence interval formulas. Might be a good idea. Margin of error and confidence interval. Guys are doing a great job today, by the way. Feel good about how this is going. And we only have a couple more, and then you're on your own. While you guys are writing that down, Matt mentioned before, partial credit. This is a 4-point question. 2 points just by knowing how to do the interval. There's 2 points for you. All right. Every little thing counts. Okay, all good. Jess, go ahead. Well, I did the plus or minus twice up here with the standard deviation. Well, it's already plus or minus 0.1516. Oh, this is just margin. The margin of error is 0.156 going either direction. And then I have to add that to the mean and subtract it from the mean. Because if you remember, where's our 95%? From what to what, if you remember? -2 to 2, right? Yes, no. I see what you're saying with negative, but this is the confidence interval is just mean plus or minus that the margin of error is just 0.156. Okay? And to get to the interval, I multiply it, I take that, subtract it from my mean, and to get to the +2, I add it to my mean. Okay? Other questions? All right, let's go back to the multiple choice now. 21. Okay, go ahead, read through. Okay, ready? Rate of change. Anybody remember the formula? Rate of change. What goes on top? Change in y's, right? Over change in x's, right? Change in y over your change in your x's. Okay, let's do the x's first because that's the easiest. From what to what am I doing the, what's my interval here? So 7 minus -7, my rate of change. Now, what do we have to find? When we plug in 7, what's our y value? When we plug in -7, what's our y value? Good thing we all have calculators, right? That we can do this in. Before we do it, though, here's why this is so darn tricky. Anybody remember pi over 2? That's in what type of units? Hannah? Radians. So if you're going to use your calculator, make sure it's in radian mode. Okay, that's why this one's a little tricky. Go. Whoa, Hannah. All right, I see you. We could change that to convert it to degrees so we don't have to worry about our calculator. Yep. What is pi? Anybody remember pi over 2? 90 degrees. Yep. Not bad. Not bad. And we also have what other key on our calculator that might help us out here when we plug in 7 and negative 7. Come on. So I don't have to physically, in my calculator, put a 7 there. Store key, yeah. So why don't we take 7, store it in for X right now. Did somebody just ask where the store key was after all this time? I do. Love me some store. You could do it that way as well. Yeah, but make sure if you graph it, radian mode, right? If you graph any trig one, it's got to be in radian mode. Okay? Yep, go, Olivia. No, that's changing. That's changing y. That's changing y over changing x. Yeah. Yep. So everyone, go ahead. I'll wait for you. I'll wait for you. Go ahead. Plug in 7. You're going to get a wacky decimal. Make sure we match here. That's what I got when I plugged in 7. Negative 0.297301. Whether you did it in radians or, like Hannah said, changed it to 90 instead and kept your calculator in degrees. And this is why you love the store key, because now all I have to do now for the second time is negative 7, store it in for X, and go up and copy paste. I don't have to retype it. Are you starting to see how valuable your calculator is to getting you to that 27 points? Yep. You just go up, start clicking. Now, have you stored in the other number yet? Okay, so that's all you're doing right there. Now hit enter. Okay. And you should press enter again so they know it's stored in there. There you go. Got it. Yeah. That's what I got. What? We all right? Because it's changing what I mean, y minus y. This came out to be positive in my calculator, but I got to subtract it. Changing y over changing x. What are we getting here, ladies, gentlemen? Choice? I'm not getting choice 1. Where are we getting these numbers? Are we matching, first of all? When I plug in 7, that's what I got. When I plug in negative 7, that's what I have here. Down here, you get 14. I divided them. About negative 0.26 when I round. Where are we going in the calculator? Make sure, if you kept pi over 2, make sure it's in radians. If you change it to 90, make sure it's in degrees. Where can I help people out here before we get to the last one? Yep, Sarah? You got these values here?
Yeah.
Over 7 minus a negative 7? That'd be 14, right?
I accidentally hit click, so I had to put in these numbers.
Okay. So you can use your fraction template. Go ahead, and then negative 0.29, and then all over 14. We should be good. You good there, Stud? Everyone all right? Last one. Another multiple choice. We're going to go to Bar Harbor, Maine, and Phoenix, Arizona. 15, everyone. We're going to end this at 15. We all right back here?
Yeah, I say a little.
Calculator deficiency.
It's a little brain deficiency.
So I did this way, and
Yeah. Okay. Here's why. Here's why. Because your calculator is going to do divided by 7 first, and then whatever that answer is, also it's going to add 7. That's why you can never go wrong with your fraction template. Always go fraction template. Okay. All right. Let's roll. Go ahead. Read through this. They give us 2 equations of sine, one for Bar Harbor and one for Phoenix, Arizona. Okay. Which of the statements, and here's the tough part right off the bat, they try to get you, can not be concluded. A lot of people say, oh, that's true, I'm done. All right, cannot be. So we're looking for the false one here. All right, the false one. So let's just read through them first so I know what to do with each equation. Average monthly temperature variation, all right, is more in Bar Harbor than it is in Phoenix. Anybody know a different name for variation that you might be more familiar with? Okay, keep going. The difference in the max and the min. Keep going. Begins with R, ends in ange. Okay, here we go. All right, so we got to do something with the range. Oh, yeah. How about this one? Remember the good old days? Midline? Oh, you will. And we got max and we got minimum. All right, we can get those from the equations. Go. What? There's an average in a sine graphs. The midline, right? We're good? Don't get me rattled. Okay, let's get going because I want to finish this. So let's go Bar Harbor. Max, min, range, and we'll do the same for Phoenix. This has nothing to do with graphing it or anything. We remember how to find max and min, I hope. All right, let's start with Bar Harbor. What's that number out in front? Amplitude. So pre-shift, one of my favorite terms, pre-shift up to 23.914 down to negative 23.94. What's my shift? 55.300. So how can I find the max? Okay, here we go. Yeah, there we go. Go. 23.914 plus 55.3. I get a max of 79.214. How do you find the min? Don't say just subtract them. Remember, you told me what? It went up to 23.94 and down to negative 23.94, and then I shifted it up. So how do I find the min? Negative 23.914 plus your 55.3. Everyone all right with that? So originally it was negative, and then I shifted it up 55.3 units. And where's my new min? 31.386 for a range of what values? Between the max and the min. What's my range? $47 point? No? A2B. Yep. Quickly on your own, go ahead. Phoenix, max, min, and range. Using the new equation. Pretty hot. 2.9. Ooh, got him. Everyone all right? Max min range for Phoenix. So we can answer the question. Everyone all good? Okay, ready? Remember, we're looking for the false one. Is the range more in Bar Harbor than in Phoenix? Yes. Okay, we're not circling it though. All right, because we're looking for the cannot one. The midline, remember where we found the midline? Midline's another name for the shift. The shift. Is the shift in Bar Harbor lower than the shift in Phoenix? Not circling it. We're looking for the false one. The maximum temperature in Bar Harbor is 79, about 79. Yeah, not circling it. We want the false one. The minimum in Phoenix is about 20. No, we found the false one. Okay. Oh, hey. 5 through 9, 27 and 30. Going to pick 6 more people tomorrow. 5 through 9, 27 and 30. Nice job today. Good job today.